Hello and welcome to the Natural Engineer Functionality and System Benefits conference call. My name is Hilda and I will be your operator for today. At this time, all participants are in a listen-only mode. Later, we will conduct a question and answer session. Please note that this event is being recorded. I will now turn the call over to Mr. Brian James. Mr. James, you may begin.
Okay, thank you very much. Well, good afternoon or good morning or wherever you are. This is a quick presentation of the features of Natural Engineer to help you understand applications. Now, during my days doing consultancy at a few companies, everyone seems to suggest that their applications are very, very complex. And basically what it is what it says on the screen here, assuming you can see this, is that an application is not necessarily complicated, it is just unknown. Over the years, these systems have been built up, and what we need to do is we need to understand exactly what we have when we're messing around with applications, when we're trying to either migrate them, modernize them, or even replace them. We need to know what these things are doing, and over the years, the documentation has gone missing. So what we need to look at is what do we really need to do when we're tackling applications. The first thing we need to do is we need to understand what this application is doing. And I'm going to take you through various bits and pieces of Natural Engineer that will help you to divide and conquer applications, extract metadata from applications, understand things about what sort of connectivity is between the applications, whether it's got different languages, whether it's got JCL, and we'll go through trying to understand what we've got. But we also need to remove the redundancy. We need to remove the dead code. We need to remove unused objects, because over time, we upgrade various functionalities and we never get around to tidying up these applications. Once we've got it into a state whereby we're now focused on the code that is actually being used by the business, then we can start doing things like componentizing it, modernizing it, bringing it up to the latest natural standards or COBOL standards or whatever. Once you've got it componentized, then you think about migrating it or moving it to a different platform or even replacing it with something else, because you know what is happening now within your application. And once you've done that, we get round to the performance and tuning of the new platform, the new paradigm of SOA or whatever. So any sort of modernization projects go through these 5 phases. And what we've got to try and do is basically, everyone's talking about the digital enterprise, very, very nice picture. But I don't know about you guys, but I deal with mainframes, and a lot of these systems, they're just not ready to use the middleware to expose the systems because everything's locked in. It's locked in to what we call, basically, spaghetti. You have spaghetti code, okay? We have the presentation layer, we have the business logic layer, we have the database access layer, all mixed together like this bundle of wires they've got there on the picture. It's spaghetti. And what we want to try and get to is what they call N-tier architecture. So you've got 2-tier architecture or 3-tier architecture. We've got to get the presentation layer out, we've got to sort out the business logic, and we've got to sort out the database access and start coming up with layers. Then within each layer, especially the business logic and the database access layer, we want to get components. We want to be able to build components, reusable components, stateless components, so that we can reuse them if we want to put a new GUI on the front end and also use them still on the 3270 mainframe. So why have I called it the pasta conundrum? Well, pasta is always a bit tricky, so we've got a poor kid here who's managed to spill spaghetti all over himself. We then want to get to layers, so we've got the lasagna. And then within the layers, we now have ravioli. So we're basically moving this from the spaghetti to the ravioli. So how are we going to get there? So what I've got, I want to take us now basically into Natural Engineer. This is Natural Engineer, and it's running under Windows. It can communicate to any server, so whether it's an LUW server, the new word for open systems, so whether it's Linux, Unix, or another Windows server where your source code is, it can talk to mainframes, BSE, BS2000, or ZOS, and it basically is a GUI talking to, via NDV, to where your source code is, especially if you're dealing with Natural. And what I'm going to do here is I'm just going to take you through the basic functionalities of Natural Engineer rather than have it all stuck on a PowerPoint. So wish me luck, here we go. So I'm going to deal with the hospital system to start with. And what you try and do first is you have to define the properties of where the code is. So we can have code on different step libs, and we can have COBOL code, we can have JCL, we can even point it to a KICS CSD table to work out where bits and pieces are. So what you're defining here is where is the source code, right? The next thing you want to define is what you want to extract, okay? Now, this is called the extract and load selection criteria. And what we're trying to do here is, a lot of companies have one big application with everything in it. All the different functionalities, all the different systems are running out of one library. And what we need to do is we need to divide that up. And you can divide it up in several ways. We can either use object ranges. We can use a user-defined file, so you can actually tell us which objects you want to put in. You can even do an entry point and say, from this entry point, pick me up everything below this entry point, and that will define my system or my subset that I want to play with. There's no point trying to run impact analysis, i.e. file changes, on 400,000 objects. It's not going to work. Right? So what you need to do is divide and conquer. Where is this file being used? I'll show you that in a minute. But we need to work on subsets of applications. We can't deal, it's too big. If you've got 20,000 objects, you cannot do that in one impact analysis. You have to break it up. And this is a way of breaking up this extract and load selection criteria. So then what you do is you basically extract and load, and it builds an application within Natural Engineer. So I'm playing with the hospital application. And other things that you can do before we start really playing with Natural Engineer is something called soft link maintenance. Okay? Change my application, so I haven't got a soft link there. What a soft link is basically when, instead of hard coding a call to a program, you call a variable name that contains the program name. You have the ability to import those into the Natural Engineer application so that you don't lose that information. You can actually gain information about what objects call each other via a soft link. So what I'm going to do now is I'm going to pick 21P01 and just basically go through some of the functions of Natural Engineer so you can see the information that you get. This is just immediately after extract and load. We haven't done anything special here. So what I'm doing now is I've picked a field. You can see the context in the middle box, and you can see how that field is being used in the application. And over here we have something called the tree view. And if I right-hand click on here, I should be able to see the source code of the object. And if I click on a map, I should be able to do a preview of the maps to see what they look like. So it's just giving you a rough idea of, cross-reference information, field information, how it's being used, how objects are being used within it. So we now start drilling down a bit more. What CRUD information have we got? Now CRUD basically means create, read, update, delete. So this particular program is accessing the patient DBM, and it's doing all four types of access. So we've got create, read, update, delete, and within that we can see what fields are being used and even redefinitions within fields. So this object is doing that DBM and those fields. And we can drill down at application level as well. So what database access is being done here, these are all the objects that are dealing with, in this case, patients, but it will show us all the different DBMs. We can also deal with object documentation. So one of the biggest problems that we have when we go on a site is the systems are not documented. They may have some documentation, they may have some lying around on a directory on Word somewhere, but it's not linked to anything. There's no one indexing it. What we can do with Natural Engineer is help you link that data to the objects. So within Engineer, we have something called object documentation. We can give it a rough title, we can give it some keywords, and then we can link it to documentation. Now the idea here was, the first link was for a program spec, and the second link was for the testing. Okay, most sites don't do that, so we'll ignore that for the minute. But basically, you can link it to any documents you like. It can be a folder, it can be a file, or it can actually be a URL. So you can link it to like a SharePoint. And once you've linked it in and click go, then it will just use the normal Windows system to actually open up the documents that you've linked to the object. Now, if we're building components, we want to be able to find these components without having to, have difficulty finding it. So we can add keywords. Okay, so the keywords are added here. We've got maintenance and patient record. There's something called keyword catalog. So if I click on maintenance, or if say patient record, that'd be more like it. I'm looking for a component that deals with patient record, then it will tell me because of the keyword maintenance. So it's a way of indexing objects and then indexing, of course, the documentation that's linked to it. So we're starting to pull together external sources of information as well as the source code metadata that we've got within Engineer about what's being used within the objects. We can also work out the internal program flow logic. I'm going to send this diagram to Visio, and what this will do is it will create a JSP diagram. A JSP diagram is nothing to do with Java server pages. It's a Jackson structured program for whoever's old enough to remember that. And basically, if I click on a box there, it will take me to the code. So I don't know if you can clearly see that. Let me make it a bit bigger. Zoom, blah, 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 150, there we go. Right, so this is the internal flow of the program. This red box here, repeat, the red box means it's an iteration, a loop. Okay, these diamond shapes means we've got decisions, and then anything else is like a sequence box. So if I click on, for instance, that box there, it will show me the source code related to it over here. If I click on another bit of source code here, it will take me to the picture that's associated with that piece of code. So it's a very quick way of understanding both reporting mode, structured mode, COBOL programs with perform, paragraph, SPU, and all this sort of stuff. Understanding the internal program flow of a COBOL natural object. If I click, for instance, here on the source code and jump to a subroutine, each subroutine in natural will have its own page. Each section or perform paragraph through range in COBOL will have its own page, and it will jump you to that page. As you can see here, this looks like some sort of validation routine because we just have a series of if conditions, one after the other. So this is a very quick way of understanding the program logic of a program. I'll just get rid of that. And I'll just tidy up this desktop because it gets a bit cluttered when we start doing these. Right, the other thing that we can do is we can start working out the relative complexity of objects to each other. So I've got the hospital system here, and if I go to application metrics, usage statistics, and then go to interactive and do select all, no data found. Okay, bear with me 2 seconds, I've forgotten to put metrics on. Application metrics, yeah, there's metrics, generate metrics. Thank you. Right, try again. Okay, right. When you do a load, in order to make it quicker, you can turn off the metrics, which I did, and we forgot all about it. So, now, I've done the metrics, and basically we've got Halstead and McCabe metrics. Now, if you get problems trying to sleep, look it up on the internet, and it'll tell you how these are calculated. But in essence, McCabe, this column on the end, is basically decision points, the number of if statements in a program. And you always have one because you chose to go in there in the first place. So this is the number of decision points. Okay, we can have a complex program with lots of decision points. We can also have a program that is just like a controlling program, and all it does is saying, if this, do this, if this, do this, if this, do this, right? So that's not a complex program. So what we need to do is we can take the McCabe index and use it with the Halstead. Halstead basically created some mathematical calculations related to operands and operators, right? And he worked out some formulas. Look it up on the internet. But basically, the only one I really use is this Halstead difficulty. So it basically comes up with how difficult is it to change an object. So if I click on that one, I can get these in order as well. So what I tend to use with these is I get a McCabe index and I get the Halstead difficulty index. And between those, I can then work out roughly how complex an object is relative to the rest of the objects in the application. And that's the key to it, it's relativity. So how the difficulty is 21p01? Well, in this case, it's more difficult than the other objects. Right? Now, in order to get some figures that make sense to you, you need to run these metrics. You know some of your more complex applications. See what numbers come out, and they will be your base mark or benchmark for how complex objects are relative to the others. And then you can use these for allocating the work or working out, you know, how difficult it might be to change some of these applications. So this is application metrics. Jump out of there. What I'm going to do now is I'm going to jump to a different application. Find it. Oh, it's here somewhere. Do that. Okay, so COB JCL-NT. And what I'm going to do here is, what we're trying to do is, we can pull together information. So like earlier on we said we can do COBOL, we can do natural, and we can do JCL. Okay, so let's say I've got a JCL object and a natural object being pulled in. Obviously that natural object could be called from the JCL. So let's see what we've got. We can find out from here what objects are actually in JCL steps. Okay, so we've got some COBOL objects. So we've got a COBOL linked object, and I've got a natural object. If I take the natural object, I want, that was what I made earlier, that one there. I can jump across to JCL Viewer. Okay, now, in JCL Viewer, I've got the step. I know the name of the batch natural nucleus. I know the name of the natural program being executed. I know what library it's come from. In this particular case, this is a JCL calling a JCL proc. Right? Now, instantly I've picked that particular step. This box down here has become active called View Database Accesses. If I click on that, it actually tells me which DDMs are being used in that JCL step. I've been able to use an entry point of this program and find all objects within it and work out that this DDM is being used in this step. This DDM may be actually being accessed via a subprogram. So I actually know which subprograms are being used in this step or potentially being used in this step. And then within here it will tell me which objects are in it. In this case it's just that batch itself. I just do a read access. Okay? So I can actually tell you, because I've linked the JCL back to the natural, which databases are being used. So I can go one step further. If I pick on this work file 1, I can actually tell you the work file record layout, because I've also gone through this entry point and said, well, hang on, JCL's got work file 1 allocated, where do I use it? So that batch has got line 430 and write work file 1. And then this is the record layout with the offsets. Okay. Now, for those of you with COBOL, we do COBOL accessing SQL databases like DB2. We do COBOL accessing Ada SQL, or I think you call it native SQL nowadays, which is using predict user views. And I can pick one out of here. I've got this COBOL source object here, COB Ada, and this is using employees via a predict user view. So all the bits that were available for the natural objects are also available for COBOL objects. And if I wanted to, from the JCL, I can start generating another Visio diagram. I'll just take a few seconds. There you go, it doesn't look much, one box, that's your JCL, but let's go down a bit more. We have some steps, and then within each step, it will tell me some information. And this is a more interesting page because I have the JCL being executed. I've got a natural object that's executed as the entry point. I've got the DDM, and I've also got the work file record layout. So, interactive diagram telling you everything about this JCL step. So I'll get rid of that for the time being. Okay, now, we've got JCL, but we haven't really got a clue how the JCL sources all talk to each other. So what we need to do now is we need to basically link it to things like CA7 or OPCA or Control-M or whatever scheduler you guys have. Now what we can do here, let me just tidy this up because it gets a bit cluttered. Right, I've got another application, there's one I made earlier. Right. Okay. Example JCL. And in here I've got some programs, CDMs, JCL, members, and POCs. Okay. And what I've done with this application is I've processed something called CA7. CA7 is a job scheduler. So what I can do now is I can say to this piece of JCL, say, okay then, so going backwards, what calls me? Right? So what triggers this piece of JCL? Is it a trigger step? Is it a data set turning up? Is it a calendar entry? Is it a scheduler? Is it another job finishing? In this particular case, it's a data set appearing. This data set has appeared, either it's been FTP across or it's come out of another job step, but this data set appearing triggers off this JCL to execute. So then we can say, okay, so we know what calls this, what is then triggered from this point down? So what JCL chain are we looking for? So we go forward from this point, just move it to one side so you can see it better, and now we can see that if, what's it called, XXAH728 is finished, it will fire off XXAH729, and it tells you the schedule from CA7, etc. So we can start pulling more information together to make it more obvious how these JCLs talk to each other. So we've got information about JCL in terms of the steps, which objects are being used, which CDMs are being used, which file layouts are being used, and we've also got the sequencing of the JCL itself. Okay, let's tidy this up. So, as you can see, there's quite a lot of cross-reference here already, some CRUD information, cross-reference information, program flow logic. So we're starting to really understand this application now. What we want to do now is basically say, well, okay, we want to do some impact analysis, or we want to find things a bit easier. So let's jump back to the hospital system, and I'm going to go to the impact criteria. So, over the years that this product's been around, what we found is basically people are really interested in two things, right? We've got loads of different options for impact analysis, but they're only really interested in two things. The first thing is, where's this literal being used? Where's this error message being used, or this error code? And the second one is, I want to change this database field, how do I do it? You know, what's the impact of it? Those are the two real things that drive change from the database and in these applications. So the first thing that we can do is literals and constants. And basically, I just need to move my papers so I can get to my keyboard. We can just put in what we want to find. And it very, very quickly will go through an application and report back all the instances of literals or constants. In my case here, I'm looking for anything that contains 9. And very, very quickly give you the information. Okay, it's not looking at comments in code. This is actual literals and constants used in the program. So this is different to a scan. Yeah, if you scan natural code, it will scan all your comments and everything else. We don't do that. This will go straight into the code. It's only the stuff that's in your code. Okay, so it's very, very quick, interactive, literal search. So we'll get rid of that. And now we'll do some proper impact analysis. So what I'm going to do is I'll pick one again I made earlier, and I'm going to look for a database field. Okay, very simple thing. So we're going to look for a database field. So the first thing we say is, well, which field do we want to find? Okay, so I'm going to look for patient ID. I then can put some excludes in. If you look through the manuals, you'll find a concept called byte lockout. I won't cover it here, but basically what it means is we can reduce noise in impact analysis, and we can stop global fields being picked up by mistake and other things by byte lockout. And then I can go to additional options. What I'm doing on additional options here is I'm trying to find all the derived fields. There's no point me changing a database field if I don't change all the fields related to it. So if I'm going to change a field, in this case, I'm going to increase it by 2 bytes. You can just see there's 2 over here. So I'm going to increase this field by 2 bytes. If I do it by 2 bytes, I've got to increase all the related fields by 2 bytes. So if I'm using it as a key, my key field's going to increase by 2 bytes. So I'm going to tell it to go and do some derived fields. So I can do execute. Thankfully, it's a smallish application, so it won't take too long. And eventually it will come back. Okay, so it's finished. And now I can start looking at the impact. So I'm on version 3, and we'll pick 21PR1 because it's a nice little juicy program. We can start playing with it. And here we can see all the impacts that it's found, all the areas in the code where patient ID is updated. So we can pick one of these. I'm going to scan through and pick that one. Okay. So we've got a field called hash P patient ID, or you probably say pound P patient ID, and it's numeric 7, and it's got a 1D at the top here. And what that means is it's derived. So this isn't a direct hit, it's derived because patient ID has been moved to it. And we can see that down the bottom here, this impact reason. And this source box will tell us where it's being used in the code, and this box here just tells us the context of the field. Okay, so from here, I can, if I wanted to, I can see the structure diagram for the impacts. I can find all the impacts within the object and why they've been found. Okay. And if I can also view it within a browser, eventually, here we go. The impacts are color-coded. You can change the colors if anyone has problems with colors. So you can see there's a derived field there that they call it fuchsia, but it's pink. And we go through, we've got red, which is a direct impact. So you can see quite quickly all the impacts within the code based on our impact analysis. We can then jump to modification if we wanted to, so I'll do that now. Now, we're in modification. Okay, some people don't do modification, but when you're doing a field length increase, it makes sense to try and let the tool do its job. So what we can do here is you can see most of these I've got category of N, which means it's not applicable. Why is it not applicable? Because it's defined in external objects. So we don't go around changing DDMs, that's the first thing. DBAs don't like it. And we also don't change, when we're dealing with this object, which is the program, the LDA at the same time. You have to do those separate. So there's one here. This is an A, an automatic change. And what this means is, because we said during the impact criteria that we're going to increase it by 2 bytes, it's now reflected that on all the stuff that it's impacted. And this is a derived field. So we've got a derived field here, and it was N7. It says, okay, we would like to make it N9. Okay, that's fine. If I don't like it, I can reject it. I can reject it here. Impact analysis does not have to be perfect in terms of the results. I can fine-tune it here. I don't have to keep rerunning impacts trying to filter things out. I can just ignore bits. Okay? So from here, I can also say, okay, well, tell me what you think you're going to do if I ask you to modify it. Again, that'll go into a browser eventually. On browser again. There you go. And it will tell me what it's going to do. So it's going to go from N7 to N9. Okay, well, that's great. That's what we wanted it to do. I'll say, yes, please, do the job, and execute modification. It will then modify this object into the modification library, so we don't overwrite the original. And we can then start doing our testing once the DDAs have pulled their finger out and changed the DDMs, and we've recatalogued all the LDAs. So very, very quickly, we can start doing impact analysis and finding out the scope of the impact. So if I go to analysis and do reports, and do all impacts, and go to Excel, and do select all, should get there hopefully. Ta-da! Right, so you can see all the impacts gone into Excel. If I wanted to, I can find the right button. Where is it? There we go, also just column width. Right, so we can see all the impacts across the application. If I wanted to, I can take this data, bung it into a pivot table, and start making charts so that we can start. There you go, we'll just do that, do that, do that. Something like this, can't remember. So we start building up charts so we can actually get numbers, quantify the size of the change. If we look at changes for each object related to the metrics, we can start giving numbers to each object. How much time is it going to take to change the object? So we're getting a lot more control over these objects. So that's impact analysis and modification. There's quite a few utilities, so let's get rid of this Excel spreadsheet. Get rid of these windows. Okay, so there's a few utilities. You've got mode conversion. That basically takes your reporting mode code and migrate it to structured mode code. Okay, so those guys who've still got reporting mode code, it will do the job. Okay, it's about 95 to 98% accurate. The reason being is there's some things that you can do in report mode code that you can't do in structured mode code. For instance, contiguous storage definitions being redefined. And then there's other things to do with out-of-hours calls whereby you reference the original buffer, which you can't do in structured mode. But you'll get warnings about those during the conversion. The other thing that you can do is a compare. So I need my keyboard again, 1 second. Okay, so I'm going to go Hospitex, which is my modification library, Hospital, get there eventually, everything. Okay, so this is a list of objects that are in my modification library, and if I pick one of these and just do compare, what I've done is I've sent it to an external compare. In this case, I think it's called KDiff3. I think it's a little freebie on there. It's quite a good little compare utility. So I've taken the source code and stripped out the bits and pieces and then bundled it through an external compare. And you can very, very quickly, you see this bar down the side here, see the differences between objects. And then if I click down here, there's another change. Okay, so someone's been messing around with the code. And you can see the differences between objects. Very, very, very quick. And this works across SPOD, and it also works for COBOL and all that sort of stuff. So very, very nice little compare utility. We'll get rid of that. Get rid of that. Okay. So that's the main one on the utilities. Let's go back to them. The keyword catalog, we mentioned it earlier. This is how you find objects. So if you've got that, you can then jump into the object documentation and get more information and then go on to the links, whether it's in SharePoint or whatever. Okay, under Advanced Services, we're now looking, how do we build components? How do we find technical business rules? Now, business rules. If someone says to you, I can find all the business rules in your source code, I'm afraid they may be lying. What they can actually find is the technical rules associated with fields. So, for instance, in the UK, you have to be 17 before you're allowed to drive. Therefore, the DVLA, the Driver Vehicle Licensing Association, or whatever they're called, have a rule that checks age against 17 before they issue you with the license. So, in the code, you'll find a field called age being checked against something called 17, a number. That is a technical implementation of a rule. Now, if you didn't know anything about the law, you would not know what that code meant. But you do know that something's happening with that field and being compared against that 17. Therefore, you find technical rules associated with fields. Someone, a business analyst, someone with knowledge of the system, knowledge of the processes, knowledge of the law, will then say, that's actually the implementation of the fact that you cannot drive before you're 17. So that's the implementation of the business rule. So someone else has to make the association for the business rules. So what Natural Engineer can do is it can find technical rules. Okay? So that's a big difference about what you're looking for. So what you try and do is we want to find validation rules. If we think about an online system, the things that happen to fields normally is validation and presentation, formatting. So when you read a file, you format it for presentation, and when you update a file, there's a load of validation rules. So what we're going to try and do here is say, okay, I want to find validation rules. And what I'm trying to say here is I want to find re-input statements within conditional statements. Okay? So if something's happening and there's a re-input in an if block, that could be a validation rule. Okay? But what we want to do, so this is defining like a template, very simple template. Then what I want to do is I want to say, okay, which application do I want to run against? I've got to find the application here somewhere, there we go. And I want to run it against this impact I did a minute ago. So I was looking for patient ID. So what I'm now trying to do is I'm saying, okay, I've got an impact analysis of patient ID with all its derived fields, and I know I want to look for validation rules where I've got something that's a re-input and in an if statement. And I can say, go and find me candidates. Go through this code, go through these impact results, and find out if I've got this sort of condition. And it's actually said I've got one. Okay, nothing like a CAN demo. All right, so validate patient. Here's what I made earlier. So what I've done is I've already gone through these code snippets. So if I do here and pick that, it will show me this validation. Now don't forget, I was looking for patient ID. It's actually showing me the validation that it's a #P patient ID, which is brilliant. That's exactly what I'm looking for, right? Because this is actually related to validation of patient ID. Yeah, this is exactly what I'm looking for. It's a little bit of snippet that I would like to use later on to build a validation subroutine, subprogram related to the patient file, related to the patient number. And so I can select this snippet and keep it for later on. And then if I really wanted to, I can now start messing around and build a skeleton subprogram which will contain all these snippets of code. I can pick up snippets from all different objects across different libraries and everything else and pull them into one object, and it will sort out the PDA for me and everything else, and it will give me a skeleton subprogram with the validation rule in it. Okay? So I can now then tailor that to my heart's content and use that moving forward. One of the biggest problems is trying to retrofit anything back into code. So let's say I find all these snippets and I say, okay, I want to change all this code to use this new subprogram. To be honest, it's probably not worth it. Yeah? Unless you're looking for something specific whereby you can replace certain types of logic, mainly on formatting, to be honest. Validation tends to build a new component which you use in the new paradigm when you move towards using components in different interfaces. So this is what business rules is all about in Engineer, is giving you the ability to find snippets and then potentially build components for the future. Get rid of that. Go back to refactoring and we've got componentization. So we can take a line range and build a component. Yeah, fine. The other thing that we want to do is we want to do similar code identification. This is again another bit of logic, normally related to formatting, but I've got a simpler case here. I'm going to say pick a piece of code and then go looking for this common block across all the applications. So I'm looking for similar blocks of code. Normally you'd see it like when you're formatting a title, like Mr. and Mrs. Ms. and all these other ones. You go and find those sort of things. You want to make a single routine that takes the code and then formats the title. Here I'm just saying, look for these 3 lines of code. I'm looking for like a repeat, an input, and a reset. Field names can be different, and I've got this thing called tolerance level, which we also call fuzzy logic. So we just carry on doing that. And then, so this defines our block, and then we say identify code, I think it's that button there. And then it's found it in all these different objects. So similar. Okay, it's a very simple example, but what you can do is find a simple formatting rule and then go and find similar code across the application, give it a bit of fuzzy logic so it's not exactly a match, and then work out all the different ways that people have coded the formatting logic, combine it into one routine, and then go back and replace it. So we're starting to consolidate code and we're starting to build components, which is what we need to move forward if we want to use SOA and everything else. Let me get rid of this somewhere, there we go. Other things that we can do under advanced services is natural for AJAX conversion. I won't cover it today, but basically we can take inline input statements and maps, create the NJX file, which is read by the layout painter in Natural One. That will create the old web page, and then we can then also go back to the code and change inputs using map to also have an if statement around it saying if star browser ID equal which GUI, I think it is, or which client, I can't remember. But anyway, it does an if statement, so if you're in the web, it will use process page, otherwise it will use the input statement. So that's what that does. Okay, so that was a very quick run through of the power user for Natural Engineer. So this is this Natural Windows interface. We can build applications, we tell it where the source code is, we tell it what to extract, we get metadata, we get cross-reference data, we can do impact analysis, we can do modification, we can do compares, we can do componentization. Very nice. Right, what we can then do is, we've got business users out there, they don't want the power user interface, they just want reports, they want to see things, pretty things. So what we give them is the web interface for Natural Engineer. Very similar to what you see in the Natural Studio interface, but this is web. Zero footprint. All you need to install is the standard Silverlight interface on the browser, set up a web server, and away you go. Just point it to a URL. So we've got some applications here. I've got the hospital application loaded. There you go, it's responding finally. And I can see all the bits and pieces. It's giving me some high-level diagrams of the application. If we look in here, we should be able to find 21P01 again. There he is. If I click on there, it'll give me some high-level overview of the object. I should be able to click on a map and see the map. Eventually, come on map. In your own time, thank you. And then hover over that, and it'll show me the list of the fields. I can do something similar to the JSP diagram, but it's a flow chart. Okay, so it's giving me a flow chart of the object. These red chevrons here will take me down to subroutines within the object. If I click on a picture, I should be able to see the source code. Ta-da! There we go. So I can mess around and start using this interface to understand the application. I don't need to do anything. This is all reporting. So a business user can come in here and try and mess around with things. I've got other applications here. So I've got COB JCL-NT, as the name suggests. It's got COBOL, JCL, and a few other bits and pieces in it. So everything you saw for natural should work for COBOL. Just wait for it to turn up. So this is accessing a PUV. You can see by these three circles. Don't ask me how they picked this icon, but that's what they got. And I can look at, move that down a bit, DB accesses. And these are all the native SQL statements within the COBOL. Okay. And then if I've got any kicks applications, COBOL kicks, CICS, I think you call it, it will come up. And do that one. I can say kicks access. Okay. Now, there's a whole load of functionality in here, and I haven't got a clue where half of it is. So what the guys did for me is this little tick box at the top is a task. So I click on the tasks, and it gives me a high-level overview of what is possible. So let me see what I've got on my little crib sheet. It says here CRUD. Right, CRUD reports. So if I pick CRUD, it's going to ask me for an application. And what did I pick? I picked hospital. I'll do OK. And it will give me interaction about the types of database accesses, the objects with the most access, and if I do a summary report, it will give me a quick overview of which objects are doing the CRUD. If I wanted to, I can export it down to Excel and start playing with the data there. I can go back to the tick box and say map xref, which is that one. It's going to ask me for an application, which, funny enough, is hospital system. Wait 1 second, there we go. And then I want a program, and then I want to do that one. I'll do OK. Now what this will do is across the top, you'll see the screens. And that's what the users understand, they see the screens. And at the bottom, we see the programs. That's what the programmers understand. So I can jump from number 2 to 21P01, and I can show that, and the user can see it at the top. And then I can go from there to somewhere else. I'll try this one, just jump around. Okay, so I can just see the screens interactively whilst I'm messing around. Okay, so we did some impact analysis earlier. So let's find this on here. Show me impact. Let's try that. Pick hospital system. Down here somewhere. There he is. Object. Okay, I want that one. I'll do OK. So, what we saw earlier with the impact element maintenance, the modification element maintenance, we now get a graphical front end to the impact analysis. Okay, so these are the different types of statements being impacted, the objects. So I've got a nice summary here, and then if I wanted to, I can drop down to the details, and it'll tell me the reasons why things are being impacted. And again, if I wanted to, I can export it to Excel and mess around with it. But also what I can do here was the project estimation I was talking about, referred to briefly earlier. I can say that the units are in days, and if I've got a McCabe index, okay, my example is not very complex, but if I had a cave of between 1 and 50, it's going to take a day per impact. If it's 51 to 100, it's going to take 1.2 days per impact. So we can start saying, okay, how many impacts are there with an object, combine that with some of the complexity metrics, and we can come up with a very, very rough project estimation. So we can actually start working on project estimations. The other thing that we can do, if I pick the tick box, is we can start linking in other bits of information. So earlier on we had object documentation. It can be shown here, but I'll skip that for the minute. But we're linking those sources in. We can also go to Predict. Predict has a lot of information. Why reinvent the wheel when I can say, show me the information in Predict? So get an out-of-house file, and I think I picked employees file. Okay, and eventually, come on, okay, there you go. We get information about the fields in the Predict file. So we're just pulling it together so you can just share information between all the different users. So that was a very quick overview of the web interface. I'm now going to just jump into the PowerPoint again. And there's our screen interact. Right, let's go on to the next one. Control slide. Now, what tends to happen is a lot of people are talking business process. Okay? And business process is great. And people go away and do loads of interviews and everything else. Now, what they don't understand is that when they talk to people, the people only tell them how they use the system, not what the system does. Okay? So if you're doing end-to-end, we've got some manual processes and then we've got system processes. And they only know which buttons they press. So I've got a classic case in point based in Kuwait where I am at the moment, and that is if a bloke has 4 wives, okay, he's allowed to have 4 wives. Don't ask me why you'd want that, but each wife has to be treated the same, so if he's got 4 wives, he's got to have 4 houses. Okay? Now, there's something in the system called secondary address, so you have a primary address and secondary address. You ask a user, he says, oh, I hit this button and enter the secondary address. There must be 3 secondary addresses. But he doesn't use that function because, thankfully, most people here only have 2 wives at the most. So he doesn't realize that there's a button there that will take them through. If you look at this picture, I've got Aris Business Process at the top. At the bottom, I've got Natural Engineer looking at the programs. Again, we don't know why the code is as it is. Someone has to link it to the business process to actually understand what the business implication is. But we can look at the program and say, hang on a minute, if you hit F9, it will give you another secondary address. So we can actually start plugging this gap. There's a gap in the middle there between what's actually happening in the system and what they're telling them when they're doing the business process diagrams to try and understand the manual and whatever. There's this gap. And this gap can only be filled in by tools to say, right, Natural Engineer will find you and tell you what's happening in the program. Is this reflected in the business process? Or the business process will have something, and we'll turn around and say, well, news to us, pal, it ain't in the code. So there's gaps. Everything can share documentation from SharePoint. So you have this picture, and we need to work out how can we get information from our source code into Aris. Now, what we've been doing recently with a customer is exactly that. So if I go to Engineer again, under Utilities, we've got something called Me to Aris Export. And it's password protected, so bear with me while I try to remember what it is. Yes, that was lucky. Right. Okay, so we have to pick a library. Surprise, surprise, I picked 21B1 again. Here we go, the object. And this local host here is pointing to where that web interface is I showed you a second ago. And what I do here is I click OK, and it generates an XML file. This XML file basically is just a pure XML file, and it's imported into Aris. Let me get rid of this picture and go through here, Webinar November. And what we do is we basically import that, and it will create what we call an EPC, an Event Procedure Chain, or something like that. So here is a diagram. This is very, very similar to what you saw earlier with the JSP diagram, but now these are functions and events. So the event is, we've got a decision here, so a decide statement. is the value A, that's the event. These are the functions that happen. If I click on there and hit F7, it will take me to the engineer interface. It will tell me information about this object. Okay, so not only have we created the diagram, but we can actually get more information from Natural Engineer Web Interface. So we've got the diagrams here. Each subroutine can have a separate page. So here's perform validation. If I click on there, you'll see here another EPC in ARIS, generated by Natural Engineer via the import, and it's now created another diagram showing the business flow of this object from a modeling perspective. Okay, so we've got functions and events. And if they're happy with this, they can use this as the foundation for building their to-be models. Because what we can give them is what is the as-is, as they call it. What is the current state of things? How do things work? And they can combine this with their information that they've already gleaned from their interviews with people and how they use the system. And we can give them much more information about what is physically possible within the application. They can choose to ignore it because it's out of scope anymore or the business functionality is not required. But this will tell them what's going on. And then if they're happy with this, they can actually change it to be what they call a BPMN 2.0 notation. So this is helping them to understand their business processes better. So we've gone from understanding a natural Adabas, COBOL, JCL system, how the interaction is working, how to get rid of the rubbish, how to modernize it potentially, or just to understand it. And now we've gone into impact analysis because we're changing database fields and everything else. And now we're moving slowly but surely towards helping people understand the business process. So we're building components if they want to go to SOA, if they want to expose it using things like web methods, integration server, and we're helping people understand their application. So that was a very, very quick run through. I think we've got about 10 minutes left if I've understood the time right. So is there any questions or anything else you want me to cover in this webinar? Thank you very much.
Hello, operator. Could you open it up for questions, please?
Thank you. We will now open up the call for questions. For any questions, please press *1 on your touchtone phone. If you wish to be removed from the question queue, please press the # or hash key. And if you are using a speakerphone, we ask that you please pick up the handset first before pressing any numbers. Again, for any questions, please press * and then 1 on your touchtone phone.
I have a question from the web. Does the Natural Engineer support Natural on the mainframe as well as Linux or Unix?
Yes, it does. Basically, there is a mainframe-only version, but the functionality is limited. What you'd normally do is you'd run it under Windows using Natural Development Server or SPOD, pointing to the mainframe, so you'd have your repository on the mainframe, your source code on the mainframe, so you don't need to move everything around, and then you'll get all this GUI information and the web information all pointing to the mainframe installation of Natural.
Thank you. There's no more questions from the web. Operator, do we have any queued up on the phone?
At this moment, we're showing no questions on the phone.
Okay. Well, thank you very much, Brian, for your presentation. We will go ahead and wrap the call up then for today. Thank you.
Ladies and gentlemen, thank you. Ladies and gentlemen, this concludes today's session. We thank you for your participation. You may now disconnect.